All right, so for this next one, it says, does a linear, exponential, or logarithmic model best fit the data? And then it says, find the model. Now, when we're doing it the first time, what we're going to do is we're going to do it longhand. We're going to calculate all the things by hand. Then, next time we'll do it, we'll use our calculator to actually get us the value and then see if they match. So first off, what we have to do is we have to plot this to see what kind of a uh, um, shape the data is. And so to save time, I've typed all those in. And when we hit the graph, we have something that looks like that. And so that's all the data points. And to me, that looks, as far as if it's linear, exponential, or logarithmic, that looks exponential. Okay, so what we're going to say is this looks exponential. Okay, so if we know it's exponential, we have then y equals a naught e to the k times x. So we're using x's and y's, so we'll just use that instead of the t. And so what we're going to do now is we're going to look at 2 points. And what I'm going to say is let's pick our first point and our last point. That should give us the most difference. And so hopefully when we use just only 2 points to find this model, that will get us close enough to the actual answer that we can, get an actual data points and get a model from it. And so what we have is we're going to plug in, 1 and 3.297 and 9 and 180.034. And then we'll see what we get from there. So if we have y, that's 3.297 equals, now a naught, we don't know. So we're going to have to say that's a naught. E to the k, well, we don't know k either. X, well, that's 1. So that's going to be our first equation. Now our second equation, we're going to use this point over here. And so that's going to be 180.034 equals a naught e to the k times, and now we have a 9. Okay. Now, if I think about this, e to the k times 1, that's just k, and this is e to the 9k, and we have a naughts and that. So it looks like a naught's probably the easiest thing to solve for, and then plug into our other equation to look for the k value. So if I take that first one, and you could take the second one, it doesn't matter. I'm just using this one because that k is just going to be k times 1, so it's going to be simpler. I'm going to say that's equal to a naught equals, now I divide by e to the k, so that's 3.297 over e to the k. Now, could I have done it here? Sure, I could have said a naught is equal to 180.034 over e to the k times 9, or 9k. Okay, so it doesn't matter which way we do it. We solve one of them for a naught. And then what do? Well, we plug this into the other equation because that's what a naught is in this equation. So let's plug it into this one. And so we get 180.034. And then we have equals 3.297 over e to the k times e to the 9k. Okay. So that's what we've done to simplify it. Now, we have this e to the k and e to the 9k and then 3.297. So let's get everything but the e values basically to the other side. So how do we do that? Well, I'm going to multiply by 1 over 3.297 here, which means I'm going to divide by it here. Okay, so now what does that leave me? Well, that leaves me with 180.034 over 3.297 equals, now here I have e to the 9k over e to the k. Okay, so that's not a problem. Look at this. We have same base, and we have things that are, about the same kind of exponents. We have 9k and k. So if we take one of those k's out of here, we can reduce. And so what we're going to do is we're going to, oh, not eraser. We want a different color. We're going to say, okay, well, one of those cancels one of those, and we have only 8k left. Okay. And so that's how we're going to do it, because remember, if you have 2 to the fourth over 2 to the third, well, that 3 cancels, and we have, basically our 0, and it cancels here, and we have 1. We're subtracting, and so this is just 1, so we just have 2. And so that's the same thing we're doing here. We're using these as kind of numbers. Our bases are 2 here. The bases are e. Then we took 4 minus 3 and we got 1. Here we took 9k minus k. We got 8k. And so that's how we're able to do this. All right, so let's then put this up here. And so we have our 180.034 over 3.297 equals e to the 8k. Well, now we can use logs and use the power rule to bring that down in front. Now remember, always take it to both sides, that log, otherwise you're going to have a wrong answer. And so now we have the ln of 180.034 over 3.297 equals 8k. Because remember, ln of e is just 1. Now we divide by 8. And so k is equal to ln of, where's my 0 here, 180 point. So that's what my k is equal to, okay? Now, do I want to write that into my formula up here? Probably not. I'm going to simplify that. And so I'm going to say that's approximately equal to, well, what is it approximately equal to? I'm not sure. So we had ln of 180.034 divided by 3.297. And that whole thing was divided by 8. And so, if I'm going even out to 4 decimal places, that's just going to be 0.5. So I'm going to call that 0.5 over here, and that makes things a lot simpler. Okay, so that's just 0.5 instead of that whole mess here. Now, what can I do with that k equals 0.5? Well, if I look up here, I need to solve for a naught too. So if I plug that in here, a naught is equal to 3.297 over e to the 0.5. Well, guess what? That is a number over a number, so I can find that one too. So let's simplify and figure out what that is equal to. Well, we have 3.297, and that's divided by e. And you know what? Let's use that whole answer. Then we don't even have to worry about saying we rounded. And we get 1.9969. So even if we round this to 2 or 3 decimal places, we're going to get 2 here. So that is going to be what I'm going to use here. So I'm going to say that is approximately 2. Okay, so we simplified to 0.5 and we simplified to 2. And this one, when we used it, we actually used the whole thing, that 0.50001, whatever, and we still got 2. So even if we use 5 or that, we should get about 2. So what does that tell us our original function is? Well, let's call the function f of x, just for most functions are f of x. Well, we have a, well, that's 2. Then we have e to the k, which was 0.5, and then it was x. And so that is how we would get to our function of these xy coordinates using longhand. Okay, and again, we just used the first point and the last point, so they were the furthest away from each other. And so, we used that point here and we used that point here, and so that gives us the best possible way to do it. If we used that point and that point, that's not going to be very good. We don't know how it looks out here, and so this one's going to give us the most accurate numbers out to the longest decimals, or out to the longest region of our graph that we have actual points. So that's what we're going to do here. Now what we're going to do is, okay, well, can we use our calculator to get that same value? Sure, we can. And what we're going to do is we're going to say, well, we're given a model in the form y equals ab to the x. That's what our calculator is going to do. It's going to give us ab to the x. It's not going to give us a naught e to the kx. And so what we need to do is figure out how to convert this into that, okay? Well, what we're going to do is we're going to say, well, let's rewrite y equals ab to the x as y equals a e to the ln of b to the x. Okay, so that's what we're going to have to do, is we're going to have to rewrite that. Now, what do we know about rules of logs? That means we can bring down our x here, and then we have y equals a e to the x times ln of b. Well, we can rewrite that ln of b first times x, And if we look at that, then we notice that this piece sort of looks like what K could be. This piece could be what A naught is. And so we're going to say A is equal to A naught. So that's just from our equation. So the A we get spit out from our calculator, we're going to call that A naught. And then our K, which we need for our function, when it comes out of the calculator, it's going to be a B. So if we take ln a B, that's going to be what K is. And so we can easily then get our equation by doing that. And so now we're going to use the same model. And so guess what? We know it's already exponential in the shape. And so let's go over and do the calculation using our calculator. So again, we have our calculated our data points, and we're going to do stat. We're going to go calc. And now we want the exponential, and that should be 0. So if you know it's 0, you can just type 0. And it'll say exponential regression. So we have L1, L2. Now there's a nice thing. If we want to see what that graph looks like, we can actually put something here. We can hit vars. We can go over here to y vars, and we'll plug it into 1. And so this is going to be our equation. Now, A, we said that was going to be A naught. Well, guess what? If we round that to 1 decimal place, that's 2, which is good. Now our B is 1.6487322661. And so remember, to get K, we have to take the ln of that, and that should give us our equation. Now we have, very, very good fit here. It's 0.999992. And so what does it look like? Well, when we said to save it in vars, it saves it over here into this thing. And so we have our whole equation right here, and it plots it automatically on our graph. And so we can see that that's a very good fit. And so the only thing we have left to do is we have to take the ln of b, and that was the 1.648 and 9, and then whatever else it was. So we'll see what this gives us and see if it gets us close to half. Yeah, it gives us pretty close to half. And so then we can say, okay, well, with all of those values, the calculator gave us f of x equals, and it gave us, again, roughly 2, and then it was 1.6489 to the x. So that's the form it gave us here. And we said, okay, well, if we take the ln of 1.6489, that's approximately 0.5, and that's equal to k. And so then we can say, okay, well, then we get our f of x equals a naught e to the 0.5 times x. And this matches what we got here. Okay, so by longhand we got that. By the calculator, we got the same thing. Okay, and so that's kind of the nice thing. The calculator will help us, and all we have to remember from the data the calculator gives us is whatever they give us for A, we call that A naught. Whatever they give us for B, we take the ln of it, and then that becomes K, and we can write our formula out like this, and we're done. So that is very helpful. And again, our calculator is very powerful. It does this for us, and we don't have to worry too much. All right. So let's pause there, and we'll come back with one more.